Good evening, students. Today we will discuss about the previous year JEE organic chemistry questions. So today I just discussed in the topic from IUPAC nomenclature and isomerization. So let us see first question here. Newman projections P, Q, R and S are shown here. So we want to find out which one represents the identical molecules. Here they gave options of the pairs P and Q, Q and S, Q and R and S. First, we want to, for our convenience, we want to simplify the, here they gave Newman projection structure. So we want to simplify these for our convenience to Sauer's projection formula. Now I write down all the structures to Sauer's projection formula for our, to write out the IUPAC nomenclature. So first, for the first structure, I wrote down the Sauer's projection formula. So this carbon is the one and the ring is the second carbon. So let's draw the structure. So here the carbon, second carbon attached with one hydroxyl group and with two methyl. So the first carbon attached with two methyl groups and one ethyl group. So first let's start the numbering of this compound. So the numbering starts from longest possible chain containing functional group. Here the functional group is OH group. So the number starts from this methyl group. This is 1, this is second carbon, this is third, this is fourth, and this is fifth. So the IUPAC nomenclature of this P compound is 2, 3, 3 trimethyl pentane 2 all. So next come to the Q structure. So first we write down the Sauer's projection. So here the first carbon contains one hydrogen and one with here OH group, here methyl group and one with ethyl group. Here CH2, CH3. And the second carbon contains two hydrogens and one methyl group. So the numbering starts from the longest chain containing functional groups. So the numbering starts here. This is 1, this is 2, this is 3, this is 4, and this is 5. So the IUPAC name of the structure is 3-ethyl 2. So here the parent carbon contains 5 carbon. So this is pentane 2 all. So here 2 all indicates the hydroxyl group which presents in the second carbon atom. So the suffix is 2 all. So come to the R structure. The projection, the Sauer's projection structure is here the first carbon contains one methyl group, one hydroxyl group, one methyl group, and the second carbon contains ethyl group CH2 CH3, two ethyl groups, and one hydrogen group. So the numbering of this is here 1, this is 2, this is 4, 3, this is 4, this is 5. So the IUPAC name is 3-ethyl 2-methyl pent 2 all. So come to the final structure. Here the first carbon contains two hydrogens and one methyl group. The second carbon contains one isopropyl group, that is CH3, here CH3, and one ethyl CH2CH3, and one hydroxyl group here. So the numbering starts from isopropyl group. So let's start numbering here. 1, 2, this is 3, this is 4, this is 5. So the IUPAC name of this structure is 3-ethyl 2-methyl pentane 3-all. So here OH group is in second position of the carbon atom. So here we can see the IUPAC name of structure Q and R. Both are same. So here they ask which one of the following options represents identical molecules. So here Q and R structure are similar molecules. So the correct option is option 3. So let's move on to the second question. Which one of the following structure has the IUPAC name 3-ethanol 2-hydroxy 4-methyl hex 3-ene 5 ionic acid? So here we have see that this prefix, the prefix that 3-ethanol 2-hydroxy, these two are substituted groups, that is 4-methyl. These three are substituted groups. Here hex is the parent hydrocarbon. So this structure contains 4, there is 6 carbon atoms like this, and here in third position, so here acid group is there. So here is acid group. So numbering start from here, from the functional group 1, 2, 3. This is 4, this is 5, this is 6. Here we see 3-ethanol. So ethanol means ethyl group with triple bond is attached in the third carbon atom. So C triple bond CH. Next 2-hydroxy, that is in second carbon atom which group is present, and in fourth position 1 methyl group is present. So here we can see 3-ene is there. So in third position 1 double bond is there. So here they mention 5 ionic acids. So here 1 triple bond. So finally we have the structure. So we also rewrite the structure like this. Here carbon, double bond carbon, this is third and fourth position carbon atoms. Here C, this is OH. Here COOH. So here C triple bond CH. Here C triple bond CH. So the final structure is like this. So the correct option is option number 4. So next, move on to the third question. The IUPAC name for the following compounds. So they give the structure. First, we draw the structure. Here CH2, CH3. So here one CH3 and here triple bond is there. So first, before naming the compound, we want to select the longest possible chain. So here the longest possible chain is this one. So which contains double bond and triple bond. If both double bond and triple bonds are present in the compound, the endings like in or an in. So this indicates double bond, this indicates triple bond. So numbers as low as possible are given to double bond and triple bond as I said. So here number starts from here 1, 2, this is 3, this is 4, this is 5, this is 6, this is 7. So the IUPAC name of this compound is 3, here we can see one methyl group is attached in third carbon atom, one and another methyl group is attached in fifth carbon atom. So we can write this as 3,5 dimethyl. So in fourth question, the propyl group is there. So here in fourth question, for alkyl group, propyl group is attached. So that possesses 4 carbon atoms. So that one is 4 propyl. Here the parent hydrocarbon contains 7 carbons. So we can write it as hep. In first position, double bond is there. So 1 E. And in sixth position, triple bond is there. So 6 ene. So the IUPAC name of the given compound is 3,5 dimethyl 4 propyl hept 1 ene 6 ene. So the correct option is 4. So let's move on to the fourth question. The correct IUPAC name of the following compound. Here they gave derivative of benzene. So here the substitutions are 1 methyl group, 1 chlorine and 1 nitro group. So there are certain rules that we need to follow while writing down the IUPAC. So here we have 6 carbon, so which forming an aromatic ring with the alternative double bonds, so which is a benzene. So here the substitutions takes place. So this we can tell it as a derivative of benzenes. So we need to careful while numbering the carbon atoms. So here 3 substitutions are there. So here common name of benzene derivative is taken as a base compound. So here the base compound is toluene, which is the methyl group which is attached with benzene is called as toluene. So we can start numbering from the base compound. So the number 1 is starts from methyl group. So here 1, this is 2, this is 3, this is 4, this is 5, this is 6. So now which is very easy to numbering this compound. So here we can we can naming the substitutions uh, based on in the first here the name of this compound is 2 chloro 1 methyl 4 nitro benzene. So here the naming of substitutions is based on alphabetical order. So chloro comes first, 2 chloro 1 methyl 4 nitro benzene. So the correct answer is option number 3. Next, move on to the fifth question. Which of the following compounds will show the maximum enol content? So here they gave the options. One is acetone. This is acetyl acetone. The option third, that is this is acetate, that is ethyl acetate. So the final one is amide group. So CONH2, this is amide group. So first we write down the ketoenol form. So for acetone, CH3, C double bond O, here CH3. The enol form of this is like this. So here no additional stability is there with enol form. So next come to the acetyl acetone. So first we write down the structure is, so the enolic form of acetyl acetate is OH, here C, CH3, CH. Here the formation of hydrogen bonding takes place. Here C, CH3, CH. So this enol form is highly stable because of intramolecular hydrogen bonding. Here intramolecular hydrogen bonding and due to extended conjugation. So among all 4, the enol content is maximum for this compound. So we also see in case of ethyl acetoacetate and acid amide, here this carbonyl group which is part of acid derivative, so which does not take part in enolization because it is already in resonance with the derivative of itself. So the correct answer is option number 2. So this acetyl acetate which shows the maximum enol content due to intramolecular hydrogen bonding and also due to extended conjugation. So next move on to the sixth question. The IUPAC name of the following compound. So here they give here the functional group is acidic group. So the number starts from here. This is 1, this is 2, this is 3, this is 4 and 5. So while naming the compound, the longest chain that have the principal functional group, which is acidic group, is chosen and numbered in such a manner so that the principal functional group gets the lowest number. So here OH group act as a substitution. Here OH group act as a substitution. So here the naming it is used as a prefix. So the final IUPAC name of this structure is 3 hydroxy 4 methyl pentanoic acid. Here the hydrocarbon contains 5 carbon, so it comes naming as pentanoic acid. So let's move on to the seventh question. What is the IUPAC name of the following compound? Here, while naming this compound, alkene, here the double bond is there, so it is a alkene. So alkene gets priority over functional group bromine and here bromine. So numbering starts from this alkene side. So the numbering starts from this methyl group. So this alkene side, this carbon is 2, this is 3, this is 4 and this methyl group is 5. So the IUPAC name of the following compound is 4-bromo premethyl pentoene. The correct option is option number 4. So next move on to the eighth question. The absolute configuration of here they give they ask the absolute configuration of the given compound. So first we write down the structure. Here H, the first carbon contains H, OH and COOH group, and the second carbon contains here H, Cl, CH3. So while finding the absolute configuration, some rules are there. So first one is higher atomic number gets senior priority. If atomic numbers are same, then we want to go to the second, third, fourth atoms. So wait till we find the point of difference. So to find out the absolute configuration, first we want to give numbering. So here we can see. So first they take it the this is first carbon. This OH group is 1. This carbon is 1. This is 2. This is 3. And this is fourth carbon atom. So first we give the priority to carbon 2. So here, so we want to find the configuration, that is RS configuration. So first we take the carbon 2. This is carbon 2. So here COOH, here H, here OH, and this side it contains HCl CH3. So here we can see see the rotation takes place anti-clockwise direction. So for anti-clockwise direction, the configuration is yes, but the least priority is in the horizontal line. So that is fourth, numbering of fourth is in the horizontal line. So the configuration reverse takes place. So it goes to S to R. So in same, now come to the third carbon atom. So we have, this is third. We consider the third one. So here H, here Cl, here CH3. So here HOH, here COOH. So the priority is first goes to chlorine atom, so which possesses higher atomic number. So Cl contains higher priority, so this contains second, and this methyl group contains third one. So the direction is goes to, so here direction is goes to anti-clockwise direction. So here, sorry, first one goes to S or to S. So this is clockwise direction. So this is anti-clockwise direction, that is S to, or here also least priority is in the fourth position, that is in horizontal line. So configuration reverse takes place. So it is S2 or configuration. So for the carbon 2, the configuration is S. For carbon 3, the configuration is R. So the absolute configuration of the given compound is 2s3r. So the option 1 is correct. Next, move on to the ninth question. The IUPAC name of the following compound is, here also they gave the benzene derivative. Here the cyanide group gets higher priority. So the numbering starts from this CN group. So number starts from here 1, this 2, this 3, 4, 5, here 6. So the IUPAC name of the compound is 2-bromo 5-hydroxy. Here the base compound is benzonitrile. So we can write it as 5-hydroxy benzonitrile. So the correct option is option number 2. 2-bromo 5-hydroxy benzonitrile. So next come to the 10th question. The number of stereoisomers obtained by bromination of trans-2-butene. Here generally cis-trans isomers are stereoisomers, that is pair of molecule which have the same formula but whose functional groups are in different orientations. If two groups attached to the carbon double bond are on the same side, it is said to be a cis alkene. If the same groups are in the opposite side, it is said to be as trans. So here they gave trans. We want to write down the trans to butene. So C double bond C, here CH3, here H, here H, here CH3, which is trans to butene, which undergoes bromination in presence of carbon tetrachloride, which forms 2,3 dibromobutane. So that is here H, Br. So here anti-addition takes place. Here the addition of bromination takes place in two possibilities. There are two possibilities of additions. So here I show you here. So first we write on the, so here the hydrogen is in inside of the view. Here methyl group is in outside. So in same, here the methyl group is in inside of the compound. Here it is in projection, it is in outside. So first the here this is first carbon, this is second carbon. So here two possibilities. One is, so here first bromine attacks in top position, that is in carbon 1 it can attack from top. So in carbon 2 it can attack from bottom. In similar, attack is happen in opposite side like this. So in first, here the bromine attack is take in downside of carbon 1. So like this, and another one attack is in top side of carbon 2. So, so it is said to be as anti-attack. This reaction is said to be anti-attack or anti-addition of bromine. So, while during addition, so this hydrogen comes down and this methyl groups comes upward. So we have like this. For first possibility, we have get this like this. Here bromine comes here, hydrogen comes down. So here hydrogen go upward and bromine is in downside. So now we can write it to the Sahas projection formula. So like this we can get here hydrogen is here methyl group, here bromine. So in this side, in carbon 2, the methyl group is in upside. So bromine is here. So let's next we can write it to Fisher projection formula. So while writing down the Fisher projection formula, the methyl group, both methyl groups are in the one side. The addition takes place one in upside and another one is in downside. So now you can see this compound has a plane of symmetry. So this will be meso compound. So this is not a optically active compound. Sorry, this is not a optically active compound. So in such a way, for the possibility of 2 also we can get a similar meso compound, but the hydrogen is in opposite side. So while the resulting both the compounds showing meso compound, so the number of stereoisomers, so here methyl, so the number of stereoisomers obtaining during bromination is 1. So the option is 1. So next move on to the 11th question. The IUPAC name of C6H5COCl is. Here we can see in C6H5, here one carbonyl group is there. So one benzene and one chlorine group is there. So the IUPAC name of this compound is benzene. Here the carbonyl group is there. So benzene carbonyl chloride. So the correct answer is option number 3, benzene carbonyl chloride. So next, move on to the 12th. Here they give a butane conformer. So here they ask to rotate carbon 2 in anti-clockwise direction of 120 degree about C2 C3 bond. So they ask the resulting conformer is what? So first we draw the conformer of butane. So here H, here H. So already they gave the anti-staggered form of butane. So this is 60 degree, this is 120 degree, this is 180 degree. So when the methyl groups, when the two methyl groups are in 180 degree, it is said to be as anti-staggered form. So here they ask to rotate the carbon 2 in anti-clockwise direction of 120 degree. So anti-clockwise direction means this methyl group. So here this is first carbon, this is second carbon. We want to rotate this second carbon. So anti-clockwise direction is opposite side. So we want to rotate this carbon atom. So for first 60 degree, this methyl group comes here, this hydrogen comes here, and this third the hydrogen comes here. So rotating 60 degree, we can get like this. So the methyl group comes here. So here is the hydrogen. Here the methyl group is there. So next 60-degree of rotation, the methyl group comes down. So here we want to rotate anti-clockwise direction of 60-degree again. So we can get like this. So here CH3 is there. So the methyl group in second carbon comes down. So here one hydrogen is there. Here one hydrogen. Here one hydrogen and here one hydrogen. So here we can see the two methyl group are placed in only 60 degree. So this is also a staggered form, but here the dihedral angle of two methyl groups are in 60 degree. So the final conformer is a Gauche form. So after rotating anti-clockwise direction in 120 degree, we get a Gauge conformer. So the correct answer is option number 3. So next move on to the 13th question. Which of the following compounds exhibits stereoisomerism? So here they gave 4 options: 2-methyl butene 1, 3-methyl butane 1, 3-methyl butanoic acid, 2-methyl butanoic acid. So here we can draw all the structures. First we write down all the structures of the given compound. 2-methyl butene 1. So first we write down the structure. Here CH2, here CH3, here double bond. Here they say 2-butene. So here 1, 2, 3, 4. So 2-methyl butene 1. Next compound is 3-methyl butene 1. So here the structure is CH3, CH3, CH double bond H2. So the structure of the third compound 3-methyl butanoic acid is CH3, CH3, here CH2, here COOH. So the fourth structure is 2-methyl butanoic acid, CH3, CH2, here CH, CH3, COOH. Among all the structures,